Good morning. 你好. Welcome to the Blockchain and the Lindy Chen channel. My name is Lindy Chen. Today is 23rd December 2019. I'm very excited to be here and share my insight about blockchain with you. Yesterday, I shared with you some blockchain terminology, including blockchain, nodes, distributed peer-to-peer networks, consensus, distributed ledger, ownership, proof of work, proof of stake, trustless and distributed consensus, hashing, hash puzzles, cryptography, DApps, and smart contract. Today, I will share with you more blockchain terminology. Hashing. Hashing is one of the most important base technology used in a blockchain. Like fingerprints on human being, hashes are the digital equivalent, providing identifiers for transactions and parties to the transaction, where there isn't a one-to-one correlation between every possible hash code and every possible transaction input value, such that all combinations are guaranteed to be unique. Hashes are, however, an extremely reliable means of protecting data integrity. Hash. A hash is the output of a one-way hash function that packages input into an output of a specific size and format. This ensures information is translated into a manageable size that also prevents the input information from being seen, further establishing the trustless element of distributed ledger technologies and blockchains. Hash puzzle. Hash puzzles are used to create computational complexity and add costs and time to the process of changing data within a block. These puzzles typically reside in the header of a block, and the node can either accept it and then add to the block, or solve the puzzle if it wants to attempt to rewrite the block. The cost and time incurred in solving these puzzles are the deterrent, and that makes the block content immutable. Cryptography. The core function of cryptography in a blockchain is to protect data from being accessed by unauthorized people or nodes. Like door locks and bank sales, cryptography is the digital equivalent. Similarly, cryptography uses key to secure and protect data. DApps. DApp is an abbreviated form for decentralized application. A dApp has its backend code running on a decentralized peer-to-peer network. Contrast this with an app where the backend code is running on centralized server. A dApp can have front-end code and use interface written in any language, just like an app that can make a call to its backend. Smart contract. Smart contract contains all the information necessary to make a transfer of ownership of an asset happen. The contracts are executed by the blockchain application. Just like transaction data, smart contracts are machine-readable instructions from the involved parties. Essentially, they are self-contained programs written in a blockchain-specific language that records when and how the changes are made in the contract transaction. Smart contract may initiate a flow of execution on the blockchain subject to the information or data provided to it. Data sources may include off-chain oracles or simply information contained with a block. Blockchain architecture. We can consider the system as many layers that stack on top of each other, hence the term blockchain stack. The layers from the bottom up, 1 to 4, are wide as follows. However, as the technology evolves, more applications and functions may be added to these foundation layers. 1. The infrastructure layer. This refers to the essential infrastructure such as computing hardware, storage, network infrastructure, and a series of nodes to process transactions. 2. The network and the protocol layer. This refers to the layer where nodes participate and apply the consensus protocol based on the determined type of blockchain network and the method of consensus to be used. 3. The service layer. This refers to the layer that enables the operation of application, cross-chain and Oracle interoperability, connectors to other technology systems, record and digital asset file stores, and of course, smart contract, which holds the policies for transaction and the network. The application layer. This is where the customers, users, interact with the blockchain, so this layer hosts the user interface, integration with application in the service layer, and business logic for the transaction. In a simple sentence, it is a diverse ecosystem of developer, user, and companies that participate in a blockchain network. It is the sum of all the layers. Blockchain fabric. Blockchain fabric refers to the underlying technology and architectures to be used to support the blockchain and its purpose. These are determined mainly by considering a range of blockchain dichotomies: private versus public, permission versus anonymous, open source versus proprietary, appended only versus editable, tokens. The representation of the tradable goods being used within that blockchain. Token include, but is not exclusive to, currency, information, points, certificates, etc. Trustless. In removing the requirement for a trusted third party, a single centralized control that oversees transactions between peers, blockchain can create a decentralized system that does not require trust. Instead, self-executing peer-to-peer transactions are carried out that are recorded and verified by the whole system, therefore removing the need for one trusted body. From myself, the team at China Direct Sourcing, the team at Freezen Technology, and the team at Blockchain Collective, thank you for watching this video series. If you like what you see and hear and want to know more about it, please subscribe our channel and contact us. Good luck with your blockchain learning journey. Enjoy the program.